I would like to introduce Joshua Alphonse from Prem AI, Power of Small Language Models, Compact Designs for Big Impact. Let's give it up for Joshua.
What's up, AIQCon? How y'all doing today? Nice. I'm here to talk to you guys about small language models and some of the rapid advancements that have happened especially within this last year that we've seen. So the rapid advancement of large language models has led to significant improvements in natural language processing. But this is also possessing some challenges due to the high computational and energy demands that comes with it. The focus has often been that creating larger and more complex models is the way to go. However, with the recent research, we've been able to shed the light on some of this untapped potential that small language models bring to the table. These compact and efficient models are challenging the notion that bigger is always better. So in this presentation, I'm just gonna have you all come and explore with me the world of small language models, their unique characteristics, and how they're revolutionizing natural language processing. So I'm Joshua. I'm directing developer relations at Prem AI. Previously worked at ByteDance and Wix, leading developer relations and just connecting with developers around the world. And just like some other on a side note, some things about me, I like to DJ, collect records, and make music. Today, I'll discuss with you the problems that small language models solve, why model size doesn't really matter in certain scenarios, where small language models fit in, and lastly, I'd like to talk about what my team has done recently in creating their own small language model as well. The evolution of language models sparks the question, can smaller language models with significantly less parametric memory emulate such emergent abilities that large language models bring to us right now? So large language models have shown and exhibit a range of emergent abilities such as summarization, translation, common sense reasoning, and it's also scaled up in size over time and on a diverse amount of large data. These abilities suggest that language models are not learning from the surface pattern of language, but also acquiring some degree of semantic and logical understanding of the real world. Although research breakthroughs and other attention mechanisms have contributed to significant advancements, the recent narrative of AI can encapsulate in one word, and that word would be scale. So increasing data, resources, model size have also helped enhance performance, but the notion that bigger is always better is something that's accepted without anyone asking any questions about it. So, however, it's essential to consider the consequences of developing applications using larger available models. So, small language models rely more on pre-existing knowledge and semantic priors that have gained knowledge through pre-training. Even when we're given these examples, they usually contradict how the knowledge is formed. So in contrast, large language models can overcome their pre-existing knowledge when provided with examples that go against it, despite potentially having stronger pre-existing knowledge and compared to smaller models. So in other words, small models stick to what they learn in pre-training, and large models can adapt to new information from examples, even if it contradicts what it's learned during the pre-training process. So what problems do small language models solve? Well, small language models are an excellent choice for scenarios where internet connectivity is limited or unavailable. They can be deployed directly to devices on premise and also service enabling local inference at scale and without relying on cloud-based infrastructures. So this makes small language models ideal for applications in remote locations, mobile devices, regulated industries, and also security is paramount when you're using small language models. Another use case here is when it comes to latency. So in applications where near instant response is crucial, such as real-time conversational AI, and also time-sensitive decision-making systems, small language models really shine because their compact size and is efficient with the architecture allows for lightning fast speeds and also minimizing the amount of latency that comes with it. So it provides for a seamless user experience as well. Now, also for organizations or individuals with budget constraints, small language models also offer a cost-effective solution. So their smaller size translates to lower computational requirements, reducing the need for expensive hardware or cloud resources. So when you're dealing with simpler tasks that don't demand full capabilities of large language models, you may want to turn your head to small language models as well. And you can perform with a fraction of the cost. So during the development and testing phases, small language models are a developer's best friend in some cases. They can be easily integrated into resource-constrained development environments, such as local machines or low-power servers. And this allows developers to quickly iterate, right, and test their applications. And then you can also fine-tune models without the costly infrastructure that large language models bring to you. Now, while large language models offer impressive out-of-the-box performance, they are not always the best to fit for a specific task. Fine-tuning small language models on domain-specific data can yield superior results. However, by focusing on narrow tasks and leveraging relevant trained data, fine-tuned small language models can capture nuances, terminology, and capture unique points due to its target domain. So in summary, small language models offer a powerful and versatile solution for a wide range of applications that enable for offline inference, handling latency constraints, and also cost constraints as well. So in plain words, small language models are fast, they're cheap, they're predictable, customizable, and they're great for privacy. So these advantages make small language models attractive for a wide range of applications. Now, again, I mentioned before that bigger isn't always better, but I'm going to tell you why size doesn't always matter all the time. So small language models are streamlined variants of large language models, as I mentioned, and they're boasting fewer parameters and simpler architectures. They're designed for efficient local data processing, making them ideal for on-device and mobile implementations to reduce complexity and enable for faster inference. Small language models are effectively trained for using smaller curated data sets and leading to greater explainability. So smaller data sets allow for better understanding and control over the model's behavior and outputs, especially for different pipelines like Retrieval-Augmented Generation. So RAG involves retrieving relevant information from external sources to augment the model's knowledge. And this is perfect for small language models. And what I'll talk about a little bit later is how we also implement this for creating small language models at Prem. So by combining small language models with RAG, developers can create powerful language AI solutions that are efficient and also user-friendly without the costs. So despite impressive capabilities from LLMs, you can suffer from a lack of precise control over the behavior. So there's going to be many scenarios where you'll have to choose where you're going to use a small language model or a large language model. But the unsupervised training approach used in large language models results in models that can generate fluent but sometimes inconsistent biased outputs. And that's something that we don't want, especially if we're working inside of the realm of customer support and other things that are domain specific towards your organization. So in contrast, small language models are trained on carefully curated data sets and they offer greater control. So while small language models offer numerous advantages, they also face certain challenges. They're not perfect. And you also have to understand the context and also the use case for them. So limited contextual understanding and inferior contextual awareness also comes from small language models, right? So due to fewer parameters, small language models may struggle to understand and generate responses, reducing accuracy and performance. Quality of output. Smaller models often provide less accurate and lower quality outputs compared to larger models, particularly in nuanced complex tasks and generalizations. So you'll also find that small language models are less creative than large language models because of the generic data that it's trained on. So you'll often see repetitive outputs, which oftentimes are actually for the certain use case isn't a bad thing, but you'll have to know when to use them. And then also, small language models are trained and offer this type of data dependency so that the performance heavily relies on high quality trained data. So if that's not the case for you, then it's going to be really hard to make a significant impact on your organization with a small language model. And then there's also scalability issues. So task-specific limitations, while small language models can be fine-tuned for specific tasks, the general applicability across the wide range of tasks could be limited to some of the adaptability and struggles for rapidly evolving information to require frequent updates for your domain. So as I mentioned before, we have some other emerging capabilities and use cases for small language models. So like I mentioned before, RAG is one of them. that also offer and generate those fluent responses based on certain data and knowledge that you're giving your model. But then also we have a few other emerging use cases like data labeling, SQL generation, and agents for function calling. So you'll often see with small language models, few-shot prompting has emerged as a powerful technique for data labeling, and then also you'll see for SQL generation as well. So when it comes to function calling with small language models, the goal is to achieve fast and accurate and efficient execution for a desired task. So traditionally with large language models, you'll see like GPT 3.5 has been used for the purpose of leveraging vast knowledge and data overall for generative capabilities. However, with such massive models come with certain drawbacks, particularly for terms of latency. And that's what I mentioned before was one of the reasons why small language models really flourish when it comes to RAG and function calling, especially for domain-specific tasks. This is where small language models are making a significant impact right now. And the prime example of this is from a model that is called inversion. And you'll also see from the graph that I have here, inversion actually outdoes the speed and the latency of GPT 3.5 by 10%. So like that amount of latency is huge when you are creating tasks that require that amount of speed and time to get done. So there's other open source models like Mistral 7B, Functionary Llama 3. So these are models that offer performance and allowing developers to customize and deploy on their own single GPUs. So the open source nature of these models democratizes the access to advanced function calling capabilities to foster the collaboration within the developer community. So this is really big for us right now. So traditionally, RAG has been associated with large language models like GPT 3.5 or GPT-4, which demonstrate impressive performance. However, these super large language models, RAG applications come with certain drawbacks, and models with billions and trillions of parameters require immense computational resources. So this is where small language models also come into play as well, and this is what we've seen at Prem when we've been creating our own small language model called Prem 1B. So I also want to just draw some attention to some other models as well. So Cohere also has been emerging in the space for some of their game-changing models that are small and also specialize in RAG, called Command R and Command R+, and they tackle these RAG use cases for organizations and enterprises very easily. So currently the dominant use case for RAG lies in customer support and knowledge retrieval, and that's what this is perfect for. So considering the cost implications of using large language models for RAG in high volume customer support scenarios, each query is processed by the model would require significant computational resources. So that's what drove us to build a small language model called Prem 1B, which is a transformer-based decoder-only small language model that is trained using next token prediction. So this architecture is based on Llama 2 and is used from Tiny Llama with flash attention. So just note that Tiny Llama was trained with a context length of 2048, and Prem 1B supports a context length of 8192. So these are just some of the findings that we found when creating and benchmarking Prem 1B as well. So the Tiny Llama model appears to be a top performer overall over here, but it shows strong performance across most tasks, particularly accelerating in Arc Easy. Then we have OPT 1.3B, which is part of the OPT pre-trained transformer series, and it performs well across the board. And then the Prem 1B model from Prem AI, shows competitive performance, especially in Arc Easy, Pika, and so forth, but it struggles a bit more in window grade compared to the top two models that we have there, with more improvements to come. So we have another model here for Prem 1B chat as well. This suggests that the chat optimization didn't significantly impact the performance on these specific benchmarks, but as time goes by, these models will definitely improve. And that's it for me. And that's it for small language models. So if you'd like to learn more, come check us out at our booth upstairs from Prem AI. And then we also have a way for you to sign up and for a promo code where we're giving away 1,000 free credits. So come join us for Prem AI, and if you want to learn more, meet us upstairs. Thank you, guys.